This is what we're talking about today, interest rates and money, because we're using geometric sequences applied financially. What does that mean? We're not talking about interest. We're talking about right here, that one thing everybody loves. Everyone loves that. So interest, you're investing in something, pay interest. For example, if you take money, put in your savings account, they want your money in their bank because the more money they have in their bank, the more they can loan out. So if you put $10,000 in your savings account, they'll give you a good interest rate. They'll say, keep it here, don't touch it for 2 years, and we'll give you money on top of that. Loan from a bank, they'll say, okay, you can have this much money, but you got to pay us this much back in return. They'll say 8% or something if you have good credit. And then depreciation, the goods they lose value over time, usage, age, new technology. The most common is cars. So this is what we're working on today, the compound interest formula. It looks complicated, but as soon as we do one problem, you're going to realize this is just really algebra 1. So what I want to do is I'm going to go through this formula real quick, and we're going to go over what compounding periods per year means. In the formula packet, on the formula page, it looks just like this. They define everything here for you, so you don't have to memorize it. Future value, that's how much money you're going to get in the future. Present value, that's how much you invest. If I'm starting with 5,000, I want to get more money, start 5,000 right there. Rate, this is always in a percentage. And then K is how much your loan is being compounded. And then N, that is the number of years. It's always a natural number. That's why we went over that. Natural means a whole number bigger than 0. Periods. It's very important. Compounding periods. 4 main ones. We have yearly. We have semi-annually. We have quarterly. Quarter. And then the last one we have monthly. So yearly is once a year, once. Semi-annually, that's twice a year. It'll be compounded. Quarterly, 4 times a year. This one monthly, 12 times. Each month they'll compound that interest rate. So the K is the same thing as compounded. So if I say that it's being compounded quarterly, K would be 4. So 4 goes here and 4 goes here. The N, that's your number of years. It might say compounded quarterly over 10 years. So if I say quarterly, 4 goes in for K, 10 years, 10 goes in for N. Remember, N is always a natural number. It's always a positive whole number bigger than 0. And the thing about it, the nominal annual rate, is that your interest rate is always used in percent form. The formula puts it back in decimal for you, so you don't have to put it in decimal form. This in decimal form, so you don't have to do it. And you'll see what I mean when I go to the next slide in the problem. So 3 things to always remember is that when you're rounding with money, always 2 decimal places, because we want 53 cents, 42 cents. Every other answer is always going to be 3 sig figs. Everything in this class is 3 sig figs unless otherwise stated. And again, natural numbers, use is always a positive whole number, bigger than 0. Here's our first example. First thing we always have to do is write down our variable. So I'll just go ahead and write down our formula again. We have FV equals PV 1 plus R over 100 K KN. Remember, you don't memorize that. Future value, we need to know our present value, our rate, our compound, and our N, number of years. So we're going to look at the problem and see how many of these we can fill in. Look at our problem. It says, here invested 5,500 Turkish lira in a savings account. Good guy. With a nominal rate of 2.45% compounded quarterly. I don't know my FV, is what I'm looking for. Present value, 5,500. My rate, I got 2.45, correct. Compounded quarterly, 4. N is 6. N is a number of years. N is always a number of years. That's never going to be decimal, always a natural number, whole number. You can't have negative years. If you had negative years, I need to call you because then you discovered time travel. You're going to help me out. So FV equals, there you go. FV equals PV. PV is 5,500 times 1 plus, and then my rate, I'm going to keep it as a percentage because it changes to decimal for you, 2.45 over 100, put it in color so everybody can see it, times k is 4, then to the power of k times n. So k is 4, n is 6. So you see that? Nice and pretty. All we do is put that in the calculator. There you go. So as you can see, I already have it typed in from last class here, but I'll go through it again. 5,500 parentheses 1. Keep all the parentheses. Parentheses are good for you. For a fraction, I do alpha y equals enter 2.45 100 times 4 parentheses to the power of 4 times 5 or 6, sorry, enter. So then that's what you should get, 6,368.09 and 9 cents. That's important. All my money. I keep track of that. Now he wants to double his investment. Determine the number of years. So now we're find n, starting with this. So double that, and I'll get this. Now that's my future value equals, and to do this now, we're going to solve for n. And we've gone over, yes, I doubled the present value because I said he wants to have twice as much money. Oh, my bad, you're right. I don't know what I was thinking. I went too fast. This should be, there you go. Thanks for pointing that out. There you go, that makes more sense. So then, now we just want to solve for this guy right here. So we want to get n on one side by itself as much as possible. First thing I'll do is divide both sides by this. When you do that, you'll end up with 2 here, and then equals 1 plus 2.45 over 100 times 4 to the 4 times n. Looks complicated, that's okay. Guess what? Graph it. It's y1, y2, find the intersection. And that'll give you your answer. Second one, I'll type in what I had here. If you look here, what I'll have to do is zoom out and look at where the intersection is. And normally if you click on one of the lines, it'll tell you what it intersects. So that's my value. And remember, when we're doing years, we're looking for x. So our x value is 28.378. Years always has to be a natural number. So this is technically more than 28. So we have to go to 29. So your answer would be 29 here. If you have a graphing calculator, I'll show you on here. Y2 is, change my window so I can find it. So it's 0, that'll be 35. That'll be 0. That should work. Make that 5. Boom, I see the intersection right there. Calc, intersect number 5. Go all the way over here. Press enter 3 times. 1, 2, 3. See? Same answer. All right, so this last example, Miller bought a car worth 26,000 euros. What is his problem? The car's value depreciates at a rate of 14.1% per year. Ooh, depreciate. Determine the value of the car after 5 years. So the key word here is depreciate. And we know we have, so we start with, that's the rate, the time, and then compounding rate. That 14.1%. If I just use that, that's a gain. 14.1% means gain. I need to represent a loss. And like this person said before, oh, that means negative. Well, that means my interest rate is now negative. Okay, that's 1, because it's once per year, and 5 years. There you go. And again, we just take our formula, equals PV, 1 plus R over 100, K, KN, and we just put in what we know.